class. Already in the previous session, I have explained the equation of motion. In chapter motion in one dimension, already I have explained the equation of motions, and there are three equations of motion. I have already explained in the previous class. V equal to u plus at, s equals to ut plus half at square, v square equals to u square plus 2es. These three equations of motion already I have explained in the previous class. Okay, and also I have explained uh, there will be different condition in this one. Okay, there will be different condition when it is moving onto the horizontal surface. Okay, when the object is in rest, so u equal to 0 or starts from rest, then u will be 0. Okay, if the object which is moving with the uniform velocity, moving with then a will be 0. Okay, these are the condition that you have to apply. Okay, and if any object is in motion and all of a sudden it is going to apply the brake. Okay, if the object is in motion and all of a sudden it is going to apply the brake, and if it is applying the brake, then in place of acceleration it will be minus a. In what condition? Once the body is in motion and all of a sudden it is going to apply the brake, then in this condition we have to apply, in place of acceleration we have to put motion, that I have explained in the previous class. Okay, and also explain if the object is falling or the object is moving under the action of gravity, that is acceleration due to gravity. If the body is moving under the action of gravity, so there will be also two conditions. Maybe the body will move from bottom to top, as well as also the body can move from top to bottom. There will be also two conditions. Okay, and if the body is moving under the action of gravity, if the body is moving under the action of gravity, so these three equations of motion, it will be changed. That means in place of, again I am telling this thing, if the body is moving under the action of gravity, these things will be changed. Okay, under the action of gravity, in place of a you have to put g, in place of s you have to put h. Okay, in place of a you have to put g, in place of s you have to put h. There will be two conditions will be there in this one. That means once you are going to write the equations of motion, so if the body is falling or if the body is under the action of gravity, so in place of a you have to put g, in place of s you have to put h, and now these things, s equals to h and a equal to g, you have to put in the above given three equations of motion. Okay, so this thing will be v equal to u plus gt, s equals h equal to ut plus half gt square, and v square equals to u square plus moving under the action of gravity. Okay, one more thing just I want to explain, if suppose the body is moving from bottom to top, that means if the object is thrown from downward to upward. If the body is thrown from downward to upward, downward to upward, then in this case you have to put, since the body is acting against the gravity, so if it is acting against the gravity, so you have to put A equal to minus G. And if the body is moving from downward to upward, just see it, if the body is thrown from downward to upward, A equal to minus G, as well as also if the body is moving from bottom to top, then in this condition it will be final velocity will be given to you, as well as final velocity will be unknown and initial velocity will be known. Got it? That is v equal to u minus gt and h equals to ut minus half gt square and v square equals to u square minus 2gh. In this one you have to put v equal to 0, a equal, underline it, I am going to underline it, a equal to minus g and v equal to 0, because once we are going to throw the object from downward to upward, then where it will go you can never imagine, in which, at by what velocity in the air it will move. That's why here I have to put v equal to 0. And opposite will be in the case of once the object is released freely from any height. This is the condition, v equal to 0. These things I am going to explain. This one is the previous session I have already explained. But since you have to solve some numerical on the basis of this one, until and unless you are not knowing what will be the condition you have to apply for solving the questions, okay, you can't solve a single question related to the equation of motion. That's why I'm going to explain these things. So see this one, if the object is moving from down to up, then in this condition final velocity will be 0 and a will be minus g. Why it will be final velocity will be 0? Because once you are going to start from here, so final velocity, by what velocity it will be in the air you can never imagine. So that means final velocity will be 0 and initial velocity, since you are throwing from, starting from earth, so initial velocity will be known, u will be known and v will be 0. And opposite, once you are going to start the if any object is released freely, so if the object is released freely, if the body is released freely from any height, then if the body is released freely from any height, then in this case a will be plus g and u will be 0. Got it? Because because the body is falling towards the gravity. If the body is falling towards the gravity, then automatically a will be plus g. If the body is falling towards the gravity, then a will be plus g. And since the body is starting from here, that means by what velocity you are going to release, you are knowing. Okay, that means opposite, just like here v equals to 0, here u will be 0, initial velocity, because here you are not knowing, by what velocity you are going to release. But once it will reach to the earth's surface, here at this height you are not knowing by what velocity we are going to release. But once you will release this freely, so once it will come to the earth's surface, you will come to know by what velocity it will reach to the earth's surface. Okay, Here you are not knowing by what air. So in the air you can't imagine this thing by what velocity it is going to release, but once it will reach to the earth's surface, immediately you will come to know by what velocity it is going to fall. Okay, that means initial velocity will be 0, and since it is finally reaching to the earth's surface, that means in that case u will be 0 and final velocity will be known. In the previous case, once the object is thrown from down to up, then in that case the final velocity was 0. Okay, because it has started from the earth's surface. And right now the second case, the object is released freely. So once it is going to release freely, so that means since it is released freely and it will finally reach to the earth's surface, therefore in place of a you have to put g plus g and u will be 0, and final velocity will be known because finally it is reaching to the earth surface. Okay, so this for now the condition will be v equal to u plus gt, h equal to ut plus half gt square, and v square equals to u square plus 2gh. These things you have to apply. Okay, this one is the condition for the from down to up. Just keep this concept in your mind. If once this concept will be clear in your mind, easily you will solve each and every question. 4 condition I have explained. One for the horizontal surface. Okay, once the object is in motion, once it is going to start from rest, once the object will be in uniform motion, once the object is going to apply the brake, then what the condition you have to apply. And right now I am going to explain 2 more conditions. Once the object is falling, acts under the action of gravity. So once the body is falling or moving from down to up under the action of gravity, so once the under the action of gravity the body will move. So in that case 2 conditions will arise, from down to up as well as from up to down. From down to up, a will be minus g because it is moving against the gravity. It is moving against the gravity. Okay, and v will be 0. Here opposite thing, that means once the body is released freely, so in this condition a will be plus g, u will be equal to 0. Okay, these are the 2 conditions that you have to apply once you are going to solve the numerical problem on the in the equation of motion in the second chapter. That means if once the concept will be clear, each and every question you can solve it easily. Okay, next coming class I will also explain how you can solve the some numericals on the basis of that one. But today I have to start the next chapter. Okay, since this one is the equation of motion, until and unless already I have explained in the very first chapter, physics is an exact science. Physics is an exact science means whatever the laws, whatever the theorem, whatever the observation, each and everything should be properly satisfied. Okay, physics is an exact science means it should be also, there will be some laws will be applied, some condition will be also there. Okay, so that means once we have explained the equation of motion in one dimension in the previous session, so today I am going to explain the third chapter, that is the laws of motion. Okay, laws of motion. What will be the, once the object will be in motion, then how many laws it will be there. Okay, so today I am going to explain the third chapter, that is the law of motion. Laws of motion. Chapter 3rd. Okay, laws of motion. That means if any object is in motion, then how many laws it will be there. Okay, already equation of motion explained. So if the object is in motion, then how many laws it will be there? Okay, until and unless we are not going to apply the force at any object, until and unless we are not going to apply the force at any object, the object can never be come into the motion. Okay, without applying the force, the object cannot be start, cannot start. Okay, that means we have to apply the force, then after that the object will come into the motion. So force in our daily life, how we have to use it. Force in our daily life. So first topic is I'm going to explain force in our daily life. How the force can be used in our daily life. You can see, uh, basically force can be applied everywhere whenever if we are going to do the different type of activity. Simply if we are going to lift any object, we have to apply the force. Simply we have to move the object from one place to another place, we have to apply the force. Simply we have to change the motion, we have to apply the force. Simply we have to change the direction, we have to also apply the force. Simply if any object is in rest, and if we have to move it, then we have to apply the force. That means each and every place there will be a requirement of force. Okay, in our daily life, for doing every type of activity, for maximum type of act, not we can say the every type of activity, for the maximum type of activity we have to use the force. Okay, now how we can define the force? Basically we can define the force is push or pull. Basically we are defining the force is a push or pull. That means if we are going to push any object, if we are going to pull any object, that means force is there. Okay, if we are going to apply the, if we are going to push any object, if we are going to pull any object, push any object, that means it will be in the terms of force. But one more scientific definition that you can explain, uh, force is an external agent. Force is an external agent by which the position of the any object can be changed. Okay, force is an external agent by which the position of the any object can be changed. That means suppose if any object is here at A, any object at A, and if you want to shift it from A to B, if this object you want to shift from A to B, you have to apply the force. That means without applying the force, the object cannot be shifted from A to B. Okay, that means force is an external agent. Why I am telling external agent? Because until and unless you are not applying the external effort, until and unless you are not applying the external effort, if you want to shift this object from A to B, you can never shift it. Okay, so that means force is an external agent by which the position of the any object can be changed. Okay, that means if any object is changing the position, then we can say this thing force has applied onto the body. One more case we can say this thing is the, if the shape and size, if any body is flexible body, if we are going to take any rubber band, if we are going to take any balloon, so if we are going to apply the force, then its shape can be changed. Balloon will be like that, and if we are applying, if we are going to press it applying the force, then immediately by applying the force its shape or size can be changed. That means if any flexible body is also there, then its body can its shape and size can be also changed. But basically in our daily life, if once we want to define it, so we can define like that: force is an external agent by which the position of the any body can be changed. Now there are two types of force basically come into the consideration. Basically there are two types of force. So we can also write force is an, it is an external agent. Force, two types: contact force, non-contact force. Contact force and non-contact force. Now going to explain contact force. How we can define the contact force? Contact force means if once any object, suppose this one is that, if once we are going to strike it, contact force, that means if one object is directly with the connection of another object and the object is come into the motion. Okay, simply this object is kept here, I am applying the force, then it is moving. So this will be contact force. This object here, suppose it is in rest, and once we are going to apply the force, then the object will come into the motion. A batsman, a cricketer is hitting a cricket ball with the use of bat. That is also a contact force. A footballer is kicking the football with their leg. This is also a contact force. So contact force and non-contact force. Contact force can be also known as visible force. Contact force can be also known as visible force. Visible force, but that means you can see it. You can observe it, how this force is acting. Once we are going to hit the cricket ball with the cricket bat, then that will be contact force. If the train different compartments is pushing, the engine is pushing the different compartments. Railway engine is pushing the different compartment attached to the engine of the train engine. So if it is pushing, this is also a contact force. Okay, then bullock cart is also example. Bullock is pushing the cart, this is also a contact force. These are the contact force because physical and interaction in between the two different body, and the body is coming into the action. So this is called the contact force. Now non-contact force is also known as invisible force. Why we are telling this thing invisible force? Just see example. If we are going to release this object freely, so it will fall like that. If once we are going to release, so see, suppose this is the earth surface, this one is the earth surface. Once we are going to release, there is no physical interaction in between the earth to this body. Okay, this is called the gravitational force. So gravitational force, we can say it a non-contact force. Okay, gravitational force, we can say it is a non-contact force. So if this object is released freely, so it will fall like that. That means no physical interaction between this chalk to the earth surface. Suppose this is the earth surface, this earth surface. So this is called the invisible force or non-contact force. If there is a no physical interaction between the one body to another body and the body comes into the action, so that is called the non-contact force. Once you can also take the example of magnet. Magnet is also a perfect example. Magnet, and take a metallic body, iron, piece of iron. Once you are going to take a magnet and keep the one nail over here, then immediately it will attracted by the magnet. That means there is a no physical interaction in between this one and this one, but even then this magnet is able to attract this nail. So this is called the non-contact force. This is also a non-contact force. So these two examples I have given. as a non-contact force. One also it is there. One example is also there. That is the electrostatic force. If two charged bodies are kept, it will be in the higher class, but try to understand. If there will be two charged bodies, and if two charged bodies are kept at some distance, then they will be able to attract. Some force will attract, some force will act in between these two charged bodies. Okay, so two types of forces, contact and non-contact force. In the class 10th, you will get the more elaboration, more expanded manner. You will get these things, but contact and non-contact force is this one only. Now, by the use of force, what the thing we can do it. Okay, so there are the different uses of forces. Okay, if the object, if we are going to apply the force at any object, then how it will be in the motion, and once it will be in motion, so what the thing can be happen. That means by applying the force, what the condition will be changed in the given object. First one, stationary object will come into the motion. To change the position of the stationary object into the motion, to change the stationary object into motion. That means if any object in the rest, then it can become into the motion. If any object is in rest, then it can become into the motion. How it can become into the motion? Already given the example. A lot of example I have given to you. If suppose once I have explained the definition of the force, I have explained a lot of example. Take, if any football is kept in the ground, and until and unless the footballer is not kicking the football, then it will never come into the motion. Okay, once the um, railway engine is there, and railway engine, until and unless it is the different compartments is not attached to the engine, it can never become into the motion. Also given the example, bullock cart. If the cart is not attached to the bullock, it cannot become into the motion. Okay, three example given. I think this is sufficient for that one. Similarly, also if we are, until and unless we are not if any cricket ball is kept on the ground, and until and unless we are not hitting it by bat, it can never become into the motion. These are the examples by which we can say this thing. By the use of force, we can change the position of the stationary object into the motion. Okay, now second one, just opposite of that. That means if any object is in motion, then we can stop it. Okay, to stop the moving object. That means if any object if any object is in motion, then we can stop it. Okay, you can see if suppose a cricketer is hitting the cricket ball, and immediately the fielder is going to stop the ball. Okay, immediately once the car is in motion, and apply the brake, that means again we are applying the force. That place the fielder also apply the force by which the ball stops. Also, once the the by the use of the car brake, we are applying the force by the use of the brakes, then immediately the car will also stop. Okay, that means to stop the moving object. That means if we want to stop the moving object, then we have to also apply the force. Okay, now third one. to change the direction. If we want to change the direction, then by the use of the force we can change the direction. If we want to change the direction by the use of the force, we can change the direction. See, if we apply the force onto the paddle, once we are using the bicycle, applying the force onto the paddle, once we are going to apply the force onto the paddle, the immediately the speed of the cyclist will be changed. As well as also by the use of handle he can change the direction by applying the force. Also, once we are going to, once the car is in motion, so by the steering wheel he can also change the direction. That means by the use of steering he is applying the force, and by that the direction of the car is going to change. Once the satellite is revolving around the earth with a constant speed, but due to the change of direction and the action of gravity, its direction will its direction is also changing. Okay, these are the example by which we can say this thing, we can also change the direction. Fourth one, to change the dimension. If we want to change the if we want to change the dimension, by applying the force we can also change the dimension. I have also given the example, take a balloon, compress it, that means force we are applying and its dimension is going to change. Take a rubber band, okay, take a rubber band, stretch it, its dimension will be also changed. Then also, and strike it with the hammer, its dimension will be also changed. These are the examples by which we can say this thing, force can also change the dimension. That means force can do a lot of things in our daily life, and these are our daily life activities. For by the use of force we can change the stationary object position into the motion. By the use of applying force we can stop the moving object. Okay, by applying the force we can also change the direction of the object. And last one, by the use of the by applying the force we can also change the dimension. Okay, these four things, by the use of the force we can do it. Now come to the laws of motion, main part of this chapter. Okay, main part of this chapter, laws of motion. There are three laws of motion, and that law has given by Newton. That law has given by Newton. So Newton's law of motion. First law. First law. What was the first law given by the Newton? So Newton has given the first law that it states that every object in this universe, okay, every object in this universe will continue its state of rest or uniform motion in a straight line unless acted upon by the some external force. Okay, that means if any object is in rest, it will be in rest. If any object will be in motion, it will be in motion until and unless we are not applying the external force, the position of the body cannot be changed. Okay, again I'm going to tell this thing. It states that uh, it states that every object in this universe will continue its state of rest or uniform motion in a straight line unless acted upon by the some external force. Okay, we can also categorize in two ways. There will be two division. Okay, first one categorize in two parts. First one for rest and second one for motion. First one for rest and second one for motion. That means if any object if any object is in if any object is in rest, it will be in rest. That means if suppose any object is in rest, then it will be in rest. How it will be in rest? Suppose if any book or any copy is kept at any place, then it will be kept at that place until and unless we are not going to apply some external force. Some external force. How we can say like that? Suppose if a ball is kept at any place, it will be there only until and unless we are not applying the force. That position cannot be changed. Okay, that position cannot be changed. So that means first one, it states that every object in this universe will in the state will continue in the state of rest unless they are acted upon by the some external force. This is the first one. Now for motion, how we can apply? Every object in this world, every object in this universe will continue the state of uniform motion unless acted upon by the some external force. That means now if any object is in motion, if any until and unless we are not applying the external force, the position of the body cannot be changed. That means it cannot be stopped. Just like for rest. For rest I have explained. For rest, if any object is kept at any place, so it will remain at their own place. Until and unless we are not applying the external force, the rest position cannot be changed. Similarly also, if any object is in motion, it will be in motion. Until and unless we are not applying the external force, the motion cannot be stopped. These are the, this one is the first law given by Newton. Okay, again I am going to define the first law of Newton. Uh, it states that every object in this universe will continue its state of rest or uniform motion unless acted upon by some external force. Okay, this one is the first law. Now come to the inertia. Next part is inertia. Inertia. How we can define the inertia? Every object, just like it is the just like the first law of Newton, the same definition can be also you can take as a inertia. Okay, the tendency of any object will continue in the state of rest or in motion even when some external force applied on it is called inertia. Just like the first law of Newton, the same condition will be also for the inertia. Inertia, the root meaning of this one, to hold the object with the roots. To hold the object with their root. That means the meaning of the inertia I am telling. To hold the object with their root. That means whatever the exact position of the object, maintain that position only. That means if any object is in rest, it should be in rest. If any object is in motion, so it should be in motion. Okay, the tendency of the any object to continue its rest position or motion in a straight line. Okay, even when some external force applied on it is called inertia. Just like in first law we have divided in two parts, for rest and for motion. In the same way also we can define inertia also two part, for rest and for motion. Okay. For rest and for motion. For rest, how we can define? Every object in this universe, or the tendency of any object, the tendency of any object to continue its position of rest, to continue its position of rest, even when some external force applied on it is called the body will be in rest. Okay, I am giving the example. Suppose any object, just like a carpet is full of dust. Okay, a carpet is full of dust. Once you are going to apply or strike with the hammer, or sorry, not hammer, with the stick, then whatever the dust particle will be there, it will come out. That means since previously it was in rest, so once we are going to apply, then immediately the dust will come out. Just like also giving the example, suppose once the bus is going to start, once the bus is going to start, once the bus is going to start, our body will move backward direction. Okay, once we are going to start, once the bus is going to start, since we are in rest position, we are in rest position, and immediately the bus is going to start in the forward direction, so body will move into the backward direction, because our body will feel just like we are leaving behind. That means since previously we are in rest, so after starting it, it will seems to be that we are previously in rest position, so again it should be in rest position. That's why our body will move in the backward direction. This one is the second example. Okay, now come to the motion. The tendency of a body, the tendency of a body will continue in the state of uniform motion, even when some external force applied, the body comes into the motion. So this is called, this one is the inertia, second part. Two examples also given, this one take also example. Suppose if we have to take a long jump, suppose we have to take a long jump. For taking a long jump, we have to run, then after that we can take a long jump, because due to the inertia motion, due to the inertia we will gain some more distance. That's why we can do a long jump. Then third one, the second one. In the same way also, once we are running, and in the field, suppose we are stripping by a stone, so once we are going to strip by a stone or strike by a stone, so since our body is in forward direction and we are obstructed by a stone, so we will move in the, our body will fall in the forward direction. This is come to the, for the motion point of inertia. That means it will hold the position of motion in the forward direction. Since from the definition I have already explained, to hold the object, if once the body is in forward direction, means I am running in the forward direction and a stone, we are struck by a stone or by stripped by a stone, so since our body is in the forward direction, so we will also move in the forward direction. That means we will fall in the forward direction. As given the example, since if we have to take a long jump, so after running, then after that we are jumping at a long distance, because once we will run, so since our body is in motion and we are taking a long, we are running also, therefore we can jump a long distance. Okay, this one is the example for the inertia. Okay, now come to the This one is the sometime we can also say the inertia and Newton's law of motion both are the same thing. We can say. Okay. Now come to the linear momentum. Momentum firstly. Momentum. The if any object having some mass and it is moving with some velocity, if any object is having some mass and it is moving with some velocity, then the product of mass and velocity is known as momentum. Okay, if any object is having some mass and if it is moving with some velocity, then the product of mass and velocity, the product of mass and velocity is known as momentum. There are two types of momentum, linear momentum and angular momentum. There are two types of momentum, linear momentum and angular momentum, but in this class simply you must be knowing about the linear momentum. So right now I'm going to explain the linear momentum. If we apply the force at any object, or if any object is having some mass and it is moving with some velocity, then the product of the mass and velocity in the direction of the applied force is called linear momentum. Linear means the the direction in which the force is applied, the body should move also in that direction. That means if any object is having some mass and it is moving with some velocity, then the product of the mass and velocity in the direction of the applied force is called linear momentum. Okay, sometime it can be also written delta P equal to m into delta V. This is also formula, but this can be applied only in the case of once the value of this V is less than C. Okay, Vc is the speed of light. That means this velocity should be less than to the velocity of the particle. Speed of light is much greater than the speed of the velocity of the particle. Okay, but basically we can also, for all type of velocity, this can be applied. Okay, these things we can also write like that, delta P equal to delta in bracket m into V. This thing can be also written, but both the things will be can be written until and unless this condition is not going to satisfy. This condition should satisfy. That means the speed of light is much greater than the speed of the particle. Only in that case both the formula will be applicable. Okay, now come to the second law of Newton. Newton's second law. What will the P equal to m into V? Its unit is Newton second, or we can also write kilogram meter per second. Okay, Newton second or kilogram meter per second. Unit can be also like that. It may be also dyne second or gram centimeter per second. This will be in CGS system. This will be in SI system. Okay, this is the formula. This is the unit of the momentum. Now come to the Newton's second law. According to Newton's second law, the rate of change of linear momentum, the rate of change of linear momentum is directly proportional to the applied force and it works in that direction in which the force had applied. The rate of change of linear momentum is, again I am telling this thing, the rate of change of linear momentum is directly proportional to the applied force, and it works in that direction in which the force has applied. Okay, that means the direction in which the force is going to apply, in the same direction the rate of change of momentum will work. Okay, suppose any body is having some mass, body mass of the body is given m. Mass of the body is given m, and initial velocity is u and final velocity is v. Initial velocity is u and final velocity is v. Okay, initially the body is moving with velocity u and finally it is moving with velocity v. Then initial velocity, initial momentum of the body, formula for momentum, mass into velocity. So since we are talking about the initial momentum, so it will be m into u. Okay, final momentum of the body, it will be m into u, final momentum m into v. This one is the two momentum. Now, according to the definition, the rate of change of linear momentum. So firstly we have to calculate change in momentum. Okay, according to the definition, the rate of change of linear momentum is directly proportional to the applied force, and it works in that direction in which the force has applied. So we have already calculated here initial momentum as well as the final momentum. Both the things I have calculated here. Right now we have to calculate firstly change in momentum. Change in momentum equal to change in final velocity, final momentum minus initial momentum. Once we are going to calculate, so final momentum m into v minus m into u. Okay, change in momentum mv minus mu. Change in momentum mv minus mu. Now if we have to calculate rate of change of momentum, that means at what time there will be change in the initial to final. That means suppose in time t there has been change. The change in time, suppose in time t there is change. So that means if once we have to calculate the rate of change, so rate of change of linear momentum, rate of change of linear momentum. Okay, rate of change of linear momentum. So rate of change already calculated here, momentum, change in momentum. What I have calculated? mv minus mu. Rate, so once we have to calculate rate, we have to apply time t. Okay, time t we have to apply. Now take out common m. Take out common m, what you will get? V minus u upon t. v minus u upon t. Okay, already by the first equation of motion we are knowing v equal to u plus at. So that means v minus u equal to at. So that is v minus u upon t equal to what? A. Got it? V equal to u plus at. This thing we are knowing from the first equation of motion. Okay, by the first equation of motion, what we are knowing? V equal to u plus at. So V minus u equal to at. So V minus u upon t equal to what? A. Got it? So till A, so that means this thing we have to put it here. That is an rate of change of linear momentum. What I have explained the definition? The rate of change of linear momentum is directly proportional to the applied force, and it works in that direction. That means try to understand the concept. The rate of change of linear momentum, rate of change of linear momentum is directly proportional to the applied force. That means this momentum will be equal to the or directly proportional to the applied force. That means this will be equal to the force. That means F. So F equal to M. In place of this one we have to put A. So M into A. And it is directly proportional, so we have to write like that. Okay, F proportional to M into A, according to the concept of Newton's second law. Okay, so rate of change of momentum is directly proportional to the applied force, and it works in that direction in which the force is applied. That means force proportional to M. In place of this one we have to put M into A, or we have to write F equal to K into MA, where K is the constant of proportionality. Constant of proportionality. So that means in place of K, since it is a constant, so if it is constant, so in place of K we can put 1. Constant means not variable. Constant means any number we can put. Okay, so that means K equal to 1. So F equal to MA. This one is the Newton's second law. Okay, this one is the Newton's second law. Again I am going to define the rate of change of momentum is directly proportional to the applied force, and it works in that direction in which the force has applied. Okay, so firstly I have calculated, firstly I have supposed it, suppose the mass of the body is m, suppose the initial velocity is u, final velocity is v. Okay, and then after that initial momentum of the body, final momentum of the body, then change in the momentum, because firstly before calculating the rate of change of momentum we have to calculate change in momentum. So that's why I have written over here change in momentum, mv minus mu. After that, once we have to calculate it at what time, how after how much time it has changed, so we have to apply rate of change of momentum. So rate of change of momentum mv minus mu by t, that is m v minus u by t, and v equal to u plus at already we are knowing from the Newton's equation of motion. V equal to first equation of motion, v equal to u plus at. So v equal to u plus at, v minus u equals to at. So a equal to v minus u by t. Now put this value in this here, f proportional to ma. Got it? This one is the Newton's first law. Second law. Newton's second law. Okay, and we can also one more method we can derive it, but I will explain this thing in the next coming class. Okay, till here I think everything is clear, and try to also solve some numerical problem also from the previous chapter, that is the motion in one dimension, because concept today I have explained the concept regarding the numerical problem. Okay, so try to solve most of the numerical problem, as well as also try to do the revision of these things. Next coming class I will explain the Newton third law, as well as one more alternative method of this one, as well as also the definition of force, as well as the definition of mass, acceleration, definition of 1 Newton, how we can, what is the unit. These things I will explain in the next coming class. Okay, thank you. And I hope so that all of you have got all these points, and try to see and try to do the revision of each and every topic, whatever the topic I'm going to explain. And if suppose I'm also explaining the concept